Hey, AP Chemisters, this is Mrs. Vanderwall bringing you the last edition of section 6.4. We had just done the thermal equilibrium problems, and now we need to talk about work. I want you guys to close your eyes and go back to the day that we were working at the lab stations. And go back and remember it was station number 3 where we were working with the pistons, with a syringe, if you will. They were on a block, and my hand was on top of that. And this is what we talked about. We said that work is negative. Keep that in mind. We said that work is, or that negative sign is very important. P delta V, where gases are involved. So that meant that pushing up and down a piston would help us out here. Would make the piston go up if the system is doing work on my hand, or my hand is doing work on the system and pushing it down. Now, something else that is really super duper important is this 1 liter atmosphere is 101.3 joules. I don't know if you recall, but do you remember that it was 101.3 kilopascals? Do you remember that? Equaled 1 atm. Well, they're kind of all related. Remember, we said that joules was the SI unit for energy, and pascals is the unit, the SI unit for pressure. So they're very much related. But if I'm going to multiply 1 liter by 1 atm, it's equal to 101.3 joules. Don't forget that. We're going to be using that a little bit later on. Now, your answer must always have a what? A sign, a positive or negative sign, and a number. The sign indicates the direction of the flow. This should look familiar. Delta E equals Q plus W. If energy flows into the system by heat, what do I call that? Do you remember? Endothermic. Should let you fill that in first, huh? Okay. And what is the sign if it goes into the system? Positive. The energy flows out of the system. It is what? You know what that is. I don't have to write it out in my terrible handwriting. It is what? Yes, exothermic. I heard you all. Excellent. And the sign is going to be what? Negative. If the system does work on the surroundings, do you remember that piston? Here's the block. All right. Here's my hand. I know I give myself 5 fingers. 5 fingers. Do you remember that? The system does work on the surroundings. What did we say work is? Do you remember that? Delta V got bigger, so delta V is positive. So negative P delta V, work is going to be negative. And if the surroundings, my hand is pushing down, remember the volume got smaller? So delta V is negative, and a negative times this negative over here, that was a positive. If this doesn't seem familiar, go back and look at station number 3. Okay? So in other words, let me pull this up here. Oops, let's do this. Come on up. So we have, if ever the system does work on the surroundings. I don't know why that just kind of like blobbed out there. What did we say? Q and W are both going to be negative. Okay, so what if surroundings works on the system? Both Q and W are going to be positive. This is kind of a review of something that we've already done earlier sections. You just took a quiz on it. We're going to kind of expand this idea on the next page. Okay, so why don't you turn the page? All right, so again, excuse the fact that my drawings may not be very legible, but hopefully you'll get it figured out. So work done by the gases, by the system, correct? What's going to happen? So here's the block, here's the little piston, here's the block again, and once again, my hand. I love my hand. And what's going on here? The piston is being pushed up. So that meant my volume started off at kind of a low volume. Maybe it started off at, let's say, 5. And then what? It got pushed up. So now my volume is maybe up to 10. So final minus initial, 10 minus 5, is a positive delta V, correct? So what does that mean? Negative P delta V is going to be a negative number. So down here, the sign positive negative if the work is done by a gas. Delta V is going to be positive. Work is going to be negative. Okay, so what's my equation? work is negative P delta V, which is negative times a positive. Therefore, work is negative. Hopefully that makes sense to you. Let's scroll down again. All right, so what if the work is done to a gas? So again, let's make the little syringe thing going. Remember back station 3, here's my hand. I love my fingers, they look great. And I'm pushing down on the syringe. So what's delta V? So if I start off, here's my syringe, here's a blow-up. Maybe this was 25 mils. I pushed it down, so now it's maybe 10 mils. Final minus initial, delta V is going to be negative 7, or 10 minus 25 is negative 15. So what's work? Work is going to be, what did we say? Work is done to a gas. From the surroundings to the gas, work is positive. And again, what's my equation? Work is negative P delta V is negative P times a what? A negative delta V, and that's a positive work. Okay, so keep this in mind. We're going to do some problems right now. Okay, look at the next problem. So it says to inflate a balloon, you must do pressure, volume, work on the surroundings. Think about it. To inflate a balloon. If you inflate a balloon from a volume of 0.100 liters, I think it's a capital L, to 1.85 liters. So man, you went from a really small volume to a really big volume against an external pressure of 1 atm. How much work is done? Okay. So what's my equation that involves gases? Well, work equals negative P delta V. Hopefully that looks familiar. All right, so let's do it. What is my pressure? It's an external pressure of 1 atm. You go from my initials 0.100, my final is 1.85. Remember, it's always final minus initial. Okay. Now use your calculator. I think you can figure out what this actually equals. Oh, because I'll put it over here. And what does this equal right here? Okay, but did I answer the question? No, I don't think so. They want it in joules. So go back up and remember what that relationship, oh, it was on the next, the prior page, sorry about that. What is the relationship between liters, atmospheres, and joules? This should look kind of familiar. Okay, there's that 101.3 again. So I multiplied negative 1.75 times 101.3 joules, and I get negative 177 joules. Okay, I'm sorry, my sig figs are, actually, they're not too bad, 3 sig figs. Does the negative work make sense? What does a negative work mean? That the system is doing work on the surroundings. So think about this. You have an external pressure. It's like, in a sense, my hand holding onto the balloon, and the volume increases. So if that's the case, work is going to be negative because the system, which is the balloon, is doing work on my hand that's surrounding it in a sense. Okay. Why don't you do problem 17 all by yourself? So pause this and see how you do. All right, so we have a very similar situation where a cylinder is equipped with a piston and expands against an external pressure. The system is doing work on the surroundings, okay? What is the work in joules done? So we'll start off with this. Now just plug in what we know. We have, let's see, we have here we go, the pressure, and then no, here's my initial, and it's going to get bigger, so here's the final. So it's expanding against my hand. I don't know if you remember that. So let me kind of, combine my terms here. So I subtract it, I get this, and I end up with, there we go, this number. But that's not what they ask for, is it? They want it in joules. So again, I need that conversion factor right here. So hopefully with 3 sig figs, you get negative 138 joules. All right, I think you're getting this. Why don't you try problem 18 on your own? Pause this, do the work. Don't just watch me do it. Figure it out yourself. Okay, so what did you find out here? The volume is going from low to high. So the balloon, or this expansion of gas, is getting bigger. It's doing work on the surroundings. As always, it seems to be that the work is going to be negative. If I were making up these problems myself, maybe I'll will one day, I would kind of switch it up. I'd make the surroundings squeeze in the volume, but that's not what it's saying here. So I'm going from a small to a large, all right, at a pressure of 15. So did you get something like this? Okay. Again, work is negative. Okay. Let's do the next. Okay, so fuel is burned. Oh, burned. It's going to get hot. I think there's some heat involved. In a cylinder, you cut to the piston. The volume expands. Once again, it's expanding from a small volume to a big volume. Work should be negative against an external pressure of 1.02 atm. In addition, oh, there's my heat. I knew there's some heat because you're burning, all right? What is the delta E for the burning of the fuel? Do you remember our equation for delta E? Isn't it Q plus W? Go ahead and first solve for maybe W. Think about what the sign of the thermal energy is and see what you get. Pause this, work it out. All right, how'd you do? Well, I got, first of all, something along this line, negative 875 joules and minus 123 joules. Wait 1 minute. Where the heck did this come from? I kind of left out some steps, didn't I? Isn't it negative 1.02 times initial or final minus initial? And then I'm not done yet. What else did I have to do? I had to convert it into the joules there. And so here's how I got the work. So negative 1.02, and here is my 1.195 initial or final minus initial, times it by this. So that's the negative 123. You didn't think I was going to show you that. So I believe when you're done with it, you get negative, what, 998. Okay. And so you have a very, very exoenergetic situation. Okay, this is our last problem. So a balloon is being inflated. In the final stages, the volume of the balloon changes from 4 million liters to 4.5 million liters by addition of that many joules of heat. Assume that the balloon expands against a constant pressure of 1 atm. Calculate the delta E for the process. I'm going to let you figure this out. Pause this, and I'll be back. Okay, how'd you do? All right, here's my equation, but I need to solve for work. I got thermal, I think, down. I think they gave me, there's that thermal energy. So the work is P or negative P delta V. So here is the negative 1 atm times, oh, final minus initial. So 0.5 times 10 to the 6th. And so we have the liters atmospheres, okay? So what's going on here? I have, when I multiply this together, I get negative 5.07 times 10 to the 7th joules. So look at the sign. Why is this a positive? What does it say? By the addition of that much energy. It absorbed that much energy. And when you absorb, it's positive Q. This is endothermic, so it's positive. You have positive 1.3 times 10 to the 8th joules plus a negative 5.07 times 10 to the 7th joules. And when you are all done, you should get, oops, you can't see it now, can you? Here we go. Oh, it's in the page. Come here. There we go. Positive 7.94 times 10 to the 7th joules. Okay, so this balloon is end up net getting some energy added to it. So the thermal energy, in a sense, outweighs the work energy. And that is it. I hope it's helpful. You'll have some problems. Have fun with that. Talk to you later. Bye-bye.